Sketch a graph of the quadratic equation and give the vertex, axis of symmetry, and intercepts. If there is no intercept, enter D and E. All right, well, to do this stuff, in order to get a graph, the most important thing that we want to get first is the location of the vertex. So to get the location of the vertex, there's a couple of things we could do. First is we could use the vertex formula, but this is a rather simple equation. It's often easier to use the completing the square process, but use the vertex formula if you prefer. So x squared plus 6x separated from the constant. Now we take 6 divided by 2, which would be, because when completing the square, you take this number, divide it by 2, which is 3 in this case, then square it. So 3 squared is 9. To balance things out, you subtract 9 on the outside of the equation. This factors very easily into just x plus half of your linear term, quantity squared, and minus 3. So the location of the vertex is at -3, -3. And that's something that we can go ahead and plot. So -3, -3, there's my vertex. And one thing that I know, because the leading term coefficient here is positive, is that my parabola is going to be opening upward here. All right, but that's not really enough to get a very good picture of the parabola. Let's see what else they want. So the next thing is the axis of symmetry. Well, the axis of symmetry is very simple, and it doesn't always lead to helpful items when graphing, but that's okay. It is very simple. It's just a vertical line, which is an equation of the form x equals some constant. And that constant happens to just be the x-coordinate of your vertex. So this vertical line, my axis of symmetry that is, should look like that right there. The y-intercept. So the y-intercept is fairly straightforward as well, especially if you have the general form, because the y-intercept for any equation is just the function evaluated at 0. So for a quadratic, we have 0 squared plus 6 times 0 plus 6. It essentially is just the constant term. So my y-intercept is up here at 6, but when we express that, we really want to make sure we express it as a point. The x-coordinate is 0, the y-coordinate is 6. So there's my y-intercept. Now, here's where the axis of symmetry can come in. Since we know the axis of symmetry tells us that everything on one side of the parabola is a mirror image of the other side of the axis of symmetry, this point right here has a mirror point 3 units on the other side of the axis of symmetry. So there's another point that exists. Now lastly, we need some x-intercepts. X-intercepts, we take the function itself, set it equal to 0, and solve. So you can either take this form here, which might factor, and if it does, that's fairly straightforward. But since we've already taken the time to put it in vertex form, it will be an easier problem just to solve from this form. All we would have to do is add 3 to both sides, which would give us 3 equals x plus 3 quantity squared. Then take the square root of both sides, but whenever you take the square root involving a variable, do be careful to use the plus or minus square root. So this is the plus or minus square root of 3 equals x plus 3, and then subtract 3 from both sides. So x equals -3 plus or minus the square root of 3. So that gives us the location of the x-intercepts. So -3 plus the square root of 3 and 0, and -3 minus the square root of 3, 0. But where do we find them on our graph? So that's where you might want to use a calculator to come up with an approximation. And in order to do that, you just need to know how to get a square root on your calculator. So If I take -3, and make sure you put the negative symbol down instead of a minus, because the calculator separates those ideas. All right, so -3 plus the square root, which is second and the x squared key, square root of 3, that is about -1.27. And you might not even need to be that accurate, so let's say -1.3. The other is -3 minus the square root, so second and the square key, and that gives me -4.7. So 1.3 and 4.7. So -1.3 would be about right there, and -4.7 might be about right there. So now we've got a few different points to sketch in the graph of our parabola. So it should look something pretty similar to this right here. Now when you draw this online, you'll choose the tool that allows you to draw a parabola with just 2 input values. One of those input values, the first one, is your vertex. So just select that tool, move your cursor over to where the vertex is, and then you just need another point that's on the parabola. So get one that's very visible. Like for instance, the y-intercept was very visible. So use that point, and then that will sketch your parabola online.